It's kind of illuminating when you are a teacher, and I had to get a couple of things sorted out here today because the laptop is, like I said, it didn't work with the pen before, and sometimes all you need to do is reboot it, and I'm hoping that's all that needs to be done this time. But to hear what kids do when there's some downtime like that is fascinating. And I heard conversations and distractions about everything known to man. And I don't think I saw that much work mathematical in nature, which leads to three possibilities. The first one is that you were so into it when you were done with your quiz that you focused, you do it thoroughly, and all is good. Second possibility is that you did not care one hoot about the do it, and you just kind of figured you would talk about the things you talked about. And then there was the third possibility, which means maybe you did the easy ones and then you didn't bother doing the rest of them, or working hard on the rest of them. Now, here's the thing. If this is your normal way of going about business, and this is how you kind of approach class every day, do you think after a while the lack of focus on the right things would portray itself on your success level? That it would affect it? I think so too. So you got to be careful in terms of what you do. Listen, if you think that every day when I come into this room I want to do math, you're out of your mind. Day like today, I'm dragging from a dog show yesterday. Is what it is. Did what we did. But what I know is that if I don't push myself forward, and if I don't in turn push the course forward, we're going to have a problem in the long run. Now, because of the extra work we did at the library the other day, and because of all the times this year when we could have been distracted and not been focused, we are in a position where we have a new lesson today, we have a new lesson tomorrow. We have a new lesson on Wednesday. Actually, on Wednesday we're going to do a pretest. And then a new lesson Thursday with whatever time we have left over from the pretest. If we don't finish it on Thursday, we'll finish it that Friday during the week when we come back. And that's it. We will have covered every single lesson of the year that you're getting a sheet on. And then we start Regents Review. And it's all because of all of the days. There must have been 10 days, 12, 15 days this year that we could have sat back and wasted the time, but we pushed forward. And that has afforded us 2 to 3 weeks of extra Regents exam review. And at the end of the day, the single most important thing you do in this class is how you do on the Regents. If you've been getting 98s all year long and you get a 78 on the Regents, it's a disappointing year. And if you've been getting 80 all year long and you get an 87 on the Regents, it's a fantastic year. The Regents really is what the game is all about. So, these are all old Regents exam questions. Let's go through them as we continue to prep. As I said, you have a test this Friday. Pre-test on Wednesday, I'm going to give it to you. You're going to work on it on Wednesday, and then I'm going to give you the answers Thursday when you first walk in the room. Anything you want to go over, we'll go over. And then I'll start, perhaps finish the last lesson of the year. If you've noticed, the lessons lately have been pretty easy. I think that continues today and tomorrow. And then we're just into Regents Review, and then the game will be upped much higher than it's been lately. Okay, so let's hope and let's pray that this actually works. Oh, okay, this is good, because I thought it needed to do it last time and it didn't do it. Of course, this is how to make your teacher look like a monkey. Because it would really be funny if every time you went for it, it kept moving. Then you'd really look like an idiot. Can we kill the lights, please? Yeah, we got it working. Good. Now, as I look through number one, it says when 5x plus 4y is subtracted from 5x minus 4y, the difference is. There are two very critical words. You can argue that there's a third critical word. What are the most important words in this question? Or command, if you will. Okay? Yeah, subtract and from. Difference is the same thing as subtract, so it's kind of redundant. From goes first. We said to you earlier in the year, if I'm going from Montauk to Patchogue, I start in Montauk. I'm going from Montauk to Patchogue, I start in Montauk. So if I'm going from this number, or this binomial, 5x minus 4y has to go first. And then I'm going to subtract. And the whole purpose of a parenthesis is as a grouping symbol. So I have to put the whole thing inside the parenthesis. And as soon as I do that, yes, I see people copying down, which means those are the people who did not do their work. Okay, so that's 5x minus 4y, distributing the negative sign, negative 5x, and then negative 4y. A 5x and a negative 5x add up to nothing. They're gone, ungats. Negative 4y and negative 4y make negative 8y. Yeah, if you thought it was 3, odds are that you reversed what went first.
Yes.
That would do it. What goes first? Starts with an F? From goes first. Always remember from goes first. Okay, next up. The accompanying diagram shows a box and whisker plot of student test scores on last year's Math 8 midterm examination. What's the median score? What do you think? 81, that's right. Here's your median, right here. That's 81. What would be the first quartile? What would it be? Come on.
71.
71. What would be the third quartile?
87.
87. What's the interquartile range? If that's not how you do range. Subtract. 87 minus 71, 16 would be your interquartile range. You actually have to do the subtraction right, okay? All right, next up. Little literal equation. P equals 2L plus 2W is equivalent to, and you'll notice that 3 of the answers all say L equals, so to me that means let's solve for L. Solve for L means get L by itself, so I'm going to minus the 2W and I get P minus 2W equals 2L. Is the L by itself yet? No, so what do I need to do? Divide by 2, die. And that's choice 1, P minus 2W over 2. And last but not least, you don't need to do number 11. That's something that used to be on the integrated algebra region. It's a topic. It's no longer there. I will say to you, do you remember how to simplify the square root of 75? And how do you break down square root of 75? What's that? 25 and 3. 25 goes into 75 3 times. And what's the square root of 25? So the simplification is 5 radical 3. That's important for our work with quadratic formulas. Okay. So, as we wind down to the year, and we may even wax a little poetic, we realize that we are almost done learning new stuff for the entire year. And, yep, and then we go forward into Regents Review, where things will be determined for good. Now, today's lesson, tomorrow's linear regression, and then there's one lesson after that. Off the top of my head, I'm forgetting the subject. And then we go Regents Review, and also a little review this week before the test. The National Climate Data Center keeps collects data on weather conditions at various locations, and some of the things they track are the elevation above sea level, the number of clear days per year, partly cloudy, and then cloudy days per year. Now, we learned the other day about bivariate data. Bi means 2, variate means change, so 2 things are changing. And the other day, we didn't do anything with numbers. We used what you call categorical data, and categorical data is data that can fit into a category, but doesn't really, you can't quantify it, you can't measure it, you can't give it a number value. So for the other day, we talked about boys and girls and superpowers. Whether you liked to be invisible, whether you wanted to be able to fly, or whatever the things were that were there. Now, in this case, however, the data is not categorical, okay? This data is what we call quantitative. Now, I know that this was taught to you last year. Quantitative involves a quantity. Quantity is a number, and that means that you can measure it. And these are all measurable items. For instance, you can measure the elevation above sea level. You can measure the mean number of clear days, partly cloudy, and cloudy days per year. And then we can take this data and we can put it on the graph. And that's exactly what was done here. And this is called a scatter plot. Now, scatter kind of means to throw about, but there's a certain sense of randomness with the scatter plot, or the word scatter. And there's nothing random at all about a scatter plot. Scatter plots are very specific. For instance, there was a city at sea level, which is 0 feet above sea level, and there were exactly 100, what is this one? Clear days. And then there was a city a little above 5,000 feet, and that had about 170 clear days. And they just paired up all the numbers, and they put a little point every time the numbers came together. And we created what you call a scatter plot. Now, the next thing that needs to be done is to create what we call a line of best fit. Now, a line of best fit is a line that, as best as possible, slices the data in half. Now, I want you to know before we start that if I had one line of best fit, and Chris had a line, and Newton had a line, and Knopp had a line, and all of our lines were slightly different, but pretty much in the same ballpark, we would all be correct. So you don't have to have one exact specific line of best fit. There's a range over which it can go. When you draw a line of best fit, the idea is to have roughly the same number of scatter points above and below. So I look at this and I think that this might be a pretty good scatter line of best fit. And if you look, there's 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 below, and the ones up above might be a little bit closer, but it's nothing extraordinary. I mean, maybe this line should be, the right end of the line should be down a hair. But again, that's why there's more than one acceptable answer to what a line of best fit is. Okay? Now, based on that line of best fit, do you think there's a connection, a correlation between your elevation above sea level and the number of clear days you have a year? Well, that's what the word correlation means. You know, you could see Tully's brain going here. He's twitching. Roughly? Well, what you have is this. Do you realize, I think this is fair to say, that the number of hours you spend studying generally increases your grade? Generally. Does it always? Does it always? No. Have you ever had a test you studied a lot for and you didn't get a high grade on it? So it's not like, hey, you go sit down in that chair for 4 hours and I guarantee you a 90. For starters, the person sitting down in the chair, or the people sitting down in chairs, what says they all started with the same amount of natural ability? Right? If one kid's really, really, really natural at math or science, they might be able to sit down and study for 10 minutes and get 100. And you might have another kid who, that kid studies for 3 hours and gets an 80. But what I can, and also, aren't some units harder than other units? But I can tell you this, if I took Peter Knopp and I did a graph all year long in math class of how much time Peter spent actually studying for his math test, and then I put his score on it, generally speaking, it would be like a scatter plot, but generally speaking, the more time Peter spent preparing for the test, the higher his grade would be. So in Peter's case, if he spent very little time, his line would start down here. And if he spent a lot of time, it would increase like this. But there would be dots above and below. It's not a perfect, it's not an exact relationship. And when it's not an exact relationship, it's called a correlation. Correlation means that things tend to go together, but it doesn't have a cause and effect. Just because you study does not guarantee you're going to get a good grade. Here's another example. Does everybody here know for a fact that smoking causes cancer? It's not true. There's a very high correlation. There's a really good chance if you smoke, you're going to get cancer. But does everybody know like a really old person who has smoked their whole life and is 90 years old? Right? There are some. There's not a lot, but there are some around. And if smoking caused cancer, they would have gotten cancer a long time ago. what we could say is this. If you line up 100 people who smoke and 100 people who don't smoke, the 100 people who smoke, there's going to be a lot more cancer on that line than there is on the line of people who don't smoke. But will some people who don't smoke get cancer? Yeah, absolutely. There are some people who don't smoke who get lung cancer. So it's just a correlation, okay? Tomorrow we'll finish up the last little touch here on scatterplots. It's very, very simple to do. All right, hasta la vista, vaya con Dios. I wish my computer would have worked right from the beginning, but tomorrow we'll touch